How to Monitor and Stop Supply Chain Attacks, a blog by our Head Information Security and Head Pre-Sales and Deployment. A supply chain attack is a cyber attack that targets the software or hardware supply chain. Instead of attacking a target organization, the attacker focuses on compromising the target suppliers to infiltrate the organization indirectly, often exploiting trust in the supply chain. Such attacks usually affect either service providers with access or software manufacturers. In recent years, such cyber attacks have become increasingly common. They've developed into a significant threat to IT security, regardless of whether the company is a supplier or a customer. Detecting and mitigating these can be challenging, but combining different approaches and leveraging advanced detection technologies enables organizations to do so. Continuous monitoring, threat intelligence, and a proactive security posture are crucial elements to detect and stop them. A machine learning network detection and response, NDR, can be crucial in detecting and combating, among others, supply chain attacks and mitigating their blast radius. Regular and continuous network traffic monitoring is essential for detecting these attacks early, which is exactly what NDR provides: real-time visibility into the network, allowing security teams to respond promptly to any suspicious activity. But before diving into this solution, let's investigate recent massive incidents. Example 1. SolarWinds Orion Supply Chain Attack. In 2020, hackers compromised SolarWinds' software build process, injecting a malicious backdoor into updates. Thousands of customers, government agencies, and Fortune 500 companies received the compromised software. Attackers remotely access sensitive networks and data. How would NDR have worked? An NDR solution, such as Exeon Trace, would have recognized in real time that SolarWinds systems were compromised, as its machine learning-based model can immediately detect illegitimate network traffic. The attackers used generated domains. Exeon Trace is very fast in detecting domains generated by algorithms. When attackers use this method, they don't have to rely on a static address to communicate with the C&C server, which could be blocked. Exeon Trace works well at detecting illegitimate traffic as it learns what legitimate web traffic looks like through supervised machine learning in the lab. Exeon generates the data itself using automated web browsers. At the customer's premises, the model continues to learn, in an unsupervised manner, what normal behavior looks like in the specific network. To do this, it doesn't need to know the content of the data traffic, only the patterns of the data flows. If there's a conspicuous change in behavior, it rings the alarm. It can, therefore, also work with encrypted data. Example 2. Move IT vulnerability exploited by Buy Lion. The MoveIt supply chain attack primarily targeted a software package called MoveIt, which is widely used for motion planning and manipulation in the field of robotics. In this case, attackers gained unauthorized access to the software's build infrastructure. The build infrastructure is the environment where the software code is compiled and packaged for distribution. The attackers then introduced malicious code into the MoveIt codebase during the build process. Once the malicious code was integrated into the software, it was distributed to users as a legitimate software update. Users unknowingly installed the compromised version of MoveIt, potentially allowing the attackers to exploit vulnerabilities, steal sensitive information, or carry out other malicious activities on the affected systems. These attacks are particularly concerning as they can compromise a large number of users who trust the integrity of software. It emphasizes the importance of securing the entire software development and distribution process to prevent unauthorized access and tampering. Software developers and maintainers need to implement robust security measures to protect against such supply chain attacks to ensure the reliability of the software they provide to users. Example 3. Compromise of an upstream server, CodeCov attack. In many attacks on software systems, the bad actors typically sneak into a central server or code storage and insert harmful elements, like malicious code or fake updates. These elements then get sent out to numerous users. However, not all tech breaches follow this pattern. Take the CodeCov incident. Though people often compare it to the SolarWinds attack, it differs in key aspects. SolarWinds involved sophisticated attackers modifying a legitimate update file in SolarWinds' Orion IT monitoring product. The altered code, hidden in the refresh internal method, activated a sneaky backdoor when loading the Inventory Manager plugin. The impact hit over 18,000 SolarWinds Orion customers, including U.S. government agencies, after the tampered update spread. In contrast, the CodeCov attack didn't involve spreading malicious code to users. Instead, the attackers exploited a flawed process in creating Docker images to grab credentials. These credentials let them tamper with the CodeCov bash uploader hosted on the CodeCov server. This uploader collects environment variables sent by customers' continuous integration/continuous delivery environments. Despite the bash uploader script residing on the compromised server, many repositories were already linked to this location for sharing their CI/CD data. The harmful code only stayed on the compromised server without spreading downstream, because the linked repositories were already set to upload data to the compromised CodeCov server. Yet this affected downstream repositories, as they unknowingly sent their information to the compromised bash uploader. The attackers reportedly infiltrated hundreds of networks using credentials obtained through the compromised bash uploader. Example 4. Dependency confusion attack. For the past few years, nearly every report on supply chain attacks has highlighted a recurring issue known as dependency confusion. This problem has gained prominence because it's a straightforward and automated type of attack. It exploits a design flaw in various open-source systems, making it a hassle-free process for attackers. Simplified explanation. Imagine you're building software that relies on a private, internally created component that isn't publicly available. A clever attacker can take advantage of this by registering a similarly named component with a higher version number on a public repository. Your software build might inadvertently pull in the attacker's version instead of your internal one. It's a sneaky maneuver that capitalizes on how software components are managed, and it's become a common point of concern in the tech security landscape. Example 5. Stolen SSL and code signing certificates. Beyond regular SSL certificates, there's code signing certificates, and opposed to certificates used for encrypting your traffic to the central server. A code signing certificate would transmit a sense of authenticity as your software has successfully been signed by the private key of your supplier. If this private key associated with the certificate now gets stolen, consequences for software security are significant. Picture it like this. The attacker gets a hold of the private code signing key and uses it to sign malicious software, just as if it were a legitimate program or update from a reputable company. A year ago, GitHub and Microsoft got their code signing keys stolen by a bunch of attackers, and just like that, it happened to AnyDesk just a few weeks ago. Remember Stuxnet, another classic example of such a sophisticated attack where the bad actors used stolen private keys to make their malicious code appear trustworthy. Why go back so far in time? Well, it was one of the first occurrences of malicious people successfully using code signing certificates to transmit this false sense of security and trust. To summarize, code signing issues are something to look out for. It can happen to organizations of all sizes, so the next time you hear about SSL and code signing certificates, know that they are not just tech jargon, but essential safeguards in the digital world, and keeping those keys secure is crucial, but still can bear danger. Example 6. Targeting the CI/CD infrastructure of developers. Imagine a sneaky attack on computer programs that not only involves slipping in harmful changes to someone's project on GitHub, but also takes advantage of a fancy system GitHub has for automating tasks. This attack goes beyond just causing trouble. It also secretly uses the automation setup to generate cryptocurrency. On GitHub, developers can set up automated processes using GitHub Actions These processes help them test and deploy their code smoothly. In this attack, the bad guys copy real projects from GitHub, make small tweaks to the automation setup, and then suggest these changes to the original project owner. If the owner accepts the changes, the harmful modifications sneak back into the project, causing all sorts of issues. Plus, in the background, the attackers are making money by mining cryptocurrency without anyone knowing. It's double trouble for both the project and the unsuspecting developers. So, how can companies protect themselves? Here are 5 ways to combat supply chain attacks and why they're efficient. 1. Anomaly detection analyzes network traffic for unusual patterns, especially in communications with external servers or unexpected data transfers. Finds anomalies in network traffic, user behavior, or system activities can be indicative of a supply chain attack. NDR tools identify anomalies by comparing current behavior to historical data or predefined norms. 2. Behavioral analysis looks for unusual or unexpected behavior in networks and monitors, for anomalies in process execution, file changes, and network communication to flag suspicious activities, such as unauthorized access or unusual data exfiltration patterns. NDR with machine learning uses behavioral analysis to establish a baseline of normal network behavior. Any deviations from the baseline could indicate suspicious activity, such as unexpected data flows or unusual communication patterns originating from the supply chain. 3. User and entity behavior analytics to monitor user and entity behavior. Identifying any unusual activities or access patterns uncovers supply chain attackers that may attempt to impersonate legitimate users or entities, and UBA can help spot such anomalies. 4. As NDR integrates with threat intelligence feeds to stay updated on the latest indicators of compromise related to supply chain attacks, it identifies and alerts on any network activity associated with known malicious entities or techniques. 5. Integrating NDR with EDR solutions can provide a comprehensive view of the network and endpoint activities, for a more holistic approach to detecting and responding to supply chain attacks. Implementing an NDR solution with metadata analysis provides security teams with comprehensive insights into network activity, regardless of encryption. This approach, complemented by system and application logs, helps identify vulnerabilities, including shadow IT devices. Unlike DPI-based NDR solutions, this approach offers holistic visibility, addressing blind spots effectively. Companies based in Germany can access tips and maturity checklists for IT security through the German Federal Office for Information Security. Beyond complying with regulations or industry-specific requirements, such as UNES Regulation 155 in the automotive sector, German-based companies must promptly report all findings to the BSI in accordance with Section 8b4. This obligation applies to individual companies and extends across supply networks. Recognizing the urgency and significance of the matter, authorities worldwide are actively contributing to the development of regulatory requirements and specifications, particularly concerning cybersecurity threats within supply chain networks. For questions or more, reach out.